Yo, what's up YouTube? This is your host Matt Stats back with another video. Guys, take a moment and to hit that subscribe button and like that video and donate to this channel to help me grow this channel. I want by the end of the month to have at least 150 subscriber, hopefully 200 subscriber. And so by the end of the year, I can have at least 1,000 subscribers. I know it can happen. Let's get it happen. Today, we are going to look at still matrices, but a different way. We're going to be doing what we call the Cramer or the Cramers Rule. Without further ado, let's get to the video. Alright, so what is it about Cramer's Rule, or if you want to say Cramer's Rule, I usually say Cramer's Rule. It basically has something we called, let me actually, so it has something that we call the coefficient. We call it, it's called coefficient determinant. So we've been looking at determinant the whole time, and now we are learning about something called coefficient determinant. What does that mean? It basically means the coefficient of, usually as you guess it, the variable x and y. It is written in a system of linear equation, which you can also write down as in a matrix. But it's written in a linear system equation instead of the actual, as you can tell, the matrix side. Not only does it have a coefficient of determinant, it also has a numerator, what we call numerator determinant. And what basically the numerator determinant is when you actually replace the output with the input. Let me give you an example. Actually, first, let me define what it is. The numerator determinant basically, it is the determinant obtained by replacing the first column, right, in the coefficient determinant by the constants which are the output, or meaning b1, b2, whatever you want to call it. What does that mean? It means you have some equation as follows: 2x plus 4y and 4x plus 3y, and that equals to 2, that equals to -7. Well, what that basically is telling us is the coefficient determinant, in this case, the coefficient determinant, what you have to do, you need to actually find it. The coefficient determinant is another way of saying the denominator determinant. Denominator. Basically what that means is the common denominator. And how do you find that denominator? You find that denominator just as you did the what we called determinant. So the determinant, when you go back to my previous videos, when you do matrix, you find a 2x2 matrix, and you're going to do a determinant. This determinant is actually called the denominator determinant. Now, let's actually give an example. Actually, no. We're going to do some exercises. No. Example first. Because after we find because now you learn about the denominator determinant, and then you also learn about the numerator determinant. Then you need to find the solution of the linear equation. Remember, we used to do that linear equation back in the previous chapter when we talk about we did the addition formula method, the substitution method, and then we find the point x and y, and you graph it on the 2D plane. This right here is the same thing, except we are using it in a matrix form using Cramers Rule. So the first thing we do, we find the denominator. The first thing we do is we find the denominator determinant, then we find the numerator determinant, and then we divide them by each. We divide each numerator determinant by the denominator determinant to find the solution for the system of linear equation, which actually is easier than doing the actual addition method or substitution method. Now, let's start to do an exercise. What we're going to do is this. We're going to do some exercise when it comes to the determinant. So, let's use Cramer's Rule, and we're going to do this, what we called a system of linear equation. So let's say we have this one. We have 3x plus 7y equals 15, and 2x plus 5y equals to 11. Okay, now we are using Cramer's Rule or Cramers Rule. Okay, so how are we going to do that now? What we are going to do is, instead of doing the addition method or the substitution method, we are going to find the determinant. So what is the determinant of this equation? Well, we're going to rewrite this as in a first thing first. Let's do first thing first. So first, rewrite this equation in matrix format. What that means is I'm gonna not care about the x and the y's and just use the coefficients of x and y. So this basically is a 2x2 matrix. So it's gonna be a 3, 2, 7, 5. Now you know how to do a 2x2 matrix, right? It's basically how you're gonna do it is very simple, right? It's very simple. All you're gonna do is, actually, you know what? I'm gonna take that one instead. All you're gonna do is you multiply the first diagonal, so 3 times 5. You subtract the second diagonal, 2 times 7, right? And what do you get? Well, what do you get? You get 3 times 15 minus 3 times 7 is 14, and that's equal to 1. So the determinant D is equal to 1. This is what we call the denominator determinant. This is the denominator determinant. Now we need to find the numerator determinant, and I'm gonna say ND for numerator determinant, and I'm gonna put a little x on the bottom, meaning I'm gonna look for the x determinant, meaning the x numerator determinant, and that would be, again, that would be from the same. Now, wherever you see wherever there is x, I'm going to replace the coefficient of x by the output. So instead of writing 3 and 2, I'm going to write 15, 11, 7, 5. And so this is the x numerator, or I should say the x numerator determinant. Okay? So what we're going to do now, we're going to do the same thing we did with the first one. We're going to do the same thing we did, we're going to do. So what does that mean? That means we're going to have 15. Let me use a different line. We're going to have 15 times 5 minus what? Minus 7 times 11. And what does that equal to? Well, that equals to what? 11 times 7. What is 15 times 5? Is equal to 75. 11 times 7 is equal to 77. And what is 75 minus 77? It's negative 2. So that means the numerator determinant for x is equal to negative 2. Now, let's use for y. And the y, I'm going to write down the x, 3 and 2, and I'm going to replace the y, the 7 and 5 for the y, by 15 and 11. So 15, 11. And so we do the same thing again. We take the first one, 3 times 11 is 33, minus 15 times 2 is 30. And what do we get? We get 3. Now guess what? All we have to do is to find the solution. We now divide ndx, actually that one is actually in orange, so I'm going to take it and put it in orange. So we're going to do ndx, so we're doing ndx over d, which is the denominator, that would be equal to negative 2 over 1, which is equal to negative 2. And we're going to do what? We're going to do ndy over d, and that will be equal to 3 over 1, which is equal to 3. That means the solution is negative 2 and 3. And this is the solution for this linear equation right here, for this one right here. So I'm going to do a second one just so you guys can actually understand better what it is that we just did. So let's do another example, a very quick example. Hopefully it's going to be a bit easier and shorter than what we actually just did right now. I'm not going to do a 3 by, actually, you know what, I could do a 3 by 2 matrix, but if I do that, it's going to be for the next video. Actually, you know what, no, I'm going to stop it right here, and I'm going to do another video where I do a 2 by 2 matrix, and then I'm going to do a 3 by 3 matrix using the Cramers Rule. Guys, thanks for watching the video. Don't forget again to donate to the channel via my Cash App, PayPal, and Zelle. They are all in the description down below. And of course, you can subscribe to the channel and hit that notification bell so you can get all the updates as to when I drop a new gem. This is Mastats. Hope to see you guys again. Until then, YouTube, Mastats out.